Welcome to another episode of the AppSec Insiders Podcast. This is a show where we discuss the hottest topics and latest trends in application security and cloud security and tell you what you need to know. For those of you who don't know who we are, we're all software developers, white hat hackers, code security experts. And when we're not recording this podcast, we help organizations of all sizes with their cybersecurity needs. If you're an AppSec professional and you're looking for an opportunity to work with some of the best in the industry, or a developer with an interest in cybersecurity, be sure to check out our careers page. That's at forwardsecurity.com/careers. We would greatly appreciate it if you'd subscribe to the podcast wherever you listen to the show, and be sure to follow us on LinkedIn and Twitter or X at Forward Security. Links are in the show notes. And just before we jump in, we will be, here's some events where you can find us coming up. We will be in Money 2020 in Las Vegas. That's October 22nd to 25th. And if you're listening to this podcast well into the future, we are in the year 2023. And we will also be at LastCon in Austin, which I think is going to be a lot of fun, actually. That's going to be October 26th and 27th. And in today's episode, we're going to be discussing, we'll be starting from where we left off last time. We're talking about ASVS, the various categories, how to test them, what their value is, things like that. Last time we left off, we did the biggie, which is validation, sanitization, and encoding. This time we talk about some other very important categories, some less sexy categories for testing. But actually, I think we might get into file uploads, which are pretty fun too. But we're going to start off with category 6, which is stored cryptography. As always with me, I have my co-host, Iman.
Yeah. Hi, guys.
Yeah. And so, Iman, do you want to start us off and give an introduction, sort of an overview of the stored cryptography category?
Yeah, it's one of the important categories, like the stored cryptography. And, it's all about like how we store sensitive information and sensitive data. And for sure, we shouldn't store sensitive data without encryption. And I've seen a lot of real world examples of breaches due to poor cryptography, or like we see a lot of customers here and there that they put their secrets in their GitHub repos, their API keys. Like, for example, like some people, like they use the same API key that they use for production. They use the same one in the sandbox or like development environment, which is not good, because it makes it worse when they store it in like the GitHub repo or in an environment variable there. That makes it worse. And they should always use Key Vault. If they're using cloud environments such as AWS, they can use AWS KMS. If they're using Azure, they can use Azure Key Vault. Or I don't know, if they use like on-prem, they can use HashiCorp. But those are one of the biggest mistakes that I've seen. Like, and there are some crazy stories, especially like poor students. They register for an AWS account. One of them, I've heard that he was a student in Canada and he registered an AWS account and like then pushed the code to the repo with his AWS key, and in like half an hour he got a $40,000 bill. Because the bots, they detected the key and they executed some of those crypto miners instances to mine some Moneros, and that poor student now should deal with AWS and a $40,000 bill.
There's just bots that are just looking for public repos with secrets
on all
in
the commits and all the commits to see any matches. And that's crazy. That's like right now GitHub has GitHub secrets, but it's still like that's sometimes they miss something here and there. But especially if you're a student and out of budget, don't do this stuff because it can be a huge mistake for you.
Yeah.
Go ahead.
So a good chunk of this category is about how you store your keys, obviously. But it's also about how you actually do the cryptographic operations.
Yeah.
And so something that I still see today, mind you, they're usually very old applications, but they're still in production today. I don't know, they haven't been tested or this part hasn't been seen. I don't know, but for whatever reason, I have seen personally some companies that are still using MD5. Some that are even using, they'll use, SHA-1, thinking, okay, well, it's not MD5, but these are, hashing algorithms that are just not considered to be secure anymore. And and I wanted to give a brief explanation. I think a lot of people who are listening to this podcast probably know, oh, MD5 is insecure, but I want to give a brief explanation as to why, because I think it's not always clear to everybody. And if this is redundant for you, apologies for this brief departure here, but when you okay, so there's two things that we talk about in this category. We talk about encryption and we talk about hashing, right? Encryption is where you use an algorithm to take data and make it unreadable, but then you also have a way to reverse that and decrypt that. Hashing is a one-way version of that. You take some string and you run some algorithm over it, and the same string in English, let's say the word apple, always turns into the same hash as long as you're using the same algorithm. So this way, when you log in and you add your password to the login screen and you hit enter, we don't look through the database to see if your password is there. We first hash your password and then look at that hash in the database and see if it matches the one that's already stored there. So there's all sorts of hashing algorithms, and the best hashing algorithm is one that is slow enough that it takes a long time to iterate through thousands of them, but is fast enough that it doesn't ruin your customer's experience when they're trying to log in or register. So generally, if it can take around a second or slightly less than a second, then you're in good shape, because what that means is that if an attacker wants to brute force your password, they're going to be running an algorithm that every time they have an iteration of a word, maybe they're using a big dictionary list of words to test against, or maybe they have a program that's coming up with random combinations of letters and numbers for them. But every time they want to test one, it takes almost a full second to hash it. So you can imagine for 1,000 passwords, that's going to be 1,000 seconds, and 1,000 passwords is not nearly enough to be able to guess somebody's password. So add to that also salting. So okay, so I don't want to go too off the rails here, but salting is another way to make the password longer. It also makes it so that the hash is unique, so that two people both using the same password, if your password is Apple and somebody else's password is Apple, they'll produce two different hashes because they'll both have extra random strings appended to them. So the one thing it does is it makes the hashes unique. The other thing it does is that it makes the actual password much, much longer before it gets hashed.
Yeah, exactly.
So back to what I was actually wanting to say in the first place, which is that there's lots of different hashing algorithms, and that one of the early popular ones was called MD5. And at the time, it worked perfectly, right? It did exactly what I described. It took long enough that it didn't annoy anybody logging in, and it was short enough that it didn't annoy anyone logging in, and it took long enough that in order to brute force a password would take a long time. Over time, computers got faster and faster and faster. And this is what I have to explain to clients generally. Because computers are so much faster now, your phone, is 100 times faster than your computer was 15 years ago. So the MD5 algorithm for that reason basically is gone. It's deprecated. We don't use it anymore. So now there's lots of other ones that we recommend. We recommend bcrypt is still going strong as long as you use a lot of iterations of it. There's also scrypt and argon, and there's what else? PBKDF2. Yeah. And so these are the recommended. So when you look at ASVS, it'll say make sure that you're using a recommended hashing algorithm. That's a big part of it. It comes up in a bunch of different verifications. So usually, if you fail on one because you're using MD5, it'll usually mean you'll fail a bunch of other MD5 items. A bunch of other ASVS items that relate to that. And there's also things like make sure you're using a strong block mode, which is a thing that happens. It's part of your encryption or hashing. I guess encryption. You can use it. Do blocking modes?
Block mode is more for like symmetric.
Yeah, I don't think that
algorithms.
they
So,
apply to hashing.
no, but
Yeah.
for hashing, actually, as you told, like the hash function should have like multiple properties. Sometimes we ask in the interview questions, like they should be non-reversible. They should have avalanche effect. They should have like be collision resistant.
Yeah.
And also they should be deterministic. Like the avalanche effect also is like, it means that like a small change in the input results in a significant change in the output. And also, as Jared told, in some cases we want to have like a hashing function that is quick to compute, but in other cases, such as like we have passwords, to avoid like such of those like attacks like brute forcing attack and like rainbow table attack, there are some solutions such as like using like key derivation or key stretching algorithms, or using salt or pepper. And there is a difference between like for salt, the thing is that you need to add a random data to the input and generate the hash, but there is a difference between salt and pepper. We store salt alongside the hash value, but for the pepper we don't store it, and we keep it secret, and we kind of in the back end we brute force that to find the appropriate hash. And other than that, like for Jared was talking about like encryption, and people, and one of the ASVS items is to not use any insecure encryption algorithm. One of them is like first of all, like what is the difference between symmetric and asymmetric algorithms? Jared, you can go ahead and talk about that, and then I can talk about like why ECB is not secure.
Sure. Okay, so when we talk about encryption, there are generally two different types that we talk about. We talk about symmetric or asymmetric. If you've ever used a private key and a public key, that is asymmetric, because you both have different values that you're going to use to encrypt or decrypt a message or sign a message. Either sign and verify or encrypt and decrypt. Symmetric is where you both have the same key. It's when you share a password. That's symmetric encryption. The algorithms that are used for each have different strengths and weaknesses. Now, I'm not a math guy, but my understanding is that let's see if I can pass this test here. So symmetric algorithms are good for encrypting large amounts of data. Asymmetric encryptions are good for encrypting smaller amounts of data. And so generally, when you encrypt a larger thing with asymmetric encryption, under the hood, there's actually some symmetric encryption happening. And then I think the private key that gets produced is used to maybe encrypt the symmetric key or something like that. And it all happens under the hood. And this is why we have block modes, to break it into chunks.
As Jared told, like asymmetric algorithms, they're like kind of slow if we want to have them. And because of that, there are some ransomwares, for example, that they go after the files and they kind of encrypt them with a symmetric algorithm. And then they're gonna first they go with the first pass with symmetric algorithm and then use a symmetric algorithm. But the other thing about a symmetric algorithm is that to achieve the same level of security as symmetric algorithm, we should have asymmetric keys that there should be larger, because for example, such as RSA, ECC, for example, RSA is dependent to prime numbers, and but for example, AES is not relying on prime numbers. That's one of the reason that for example, you need to have larger keys for asymmetric algorithms to have the same level of security as symmetric algorithms. On the other hand, for example, AES has different modes. This is one of the issues that we see in clients, and this is one of the ASVS items. And one of the modes is ECB. Some clients, they use ECB, which is not recommended. because ECB encrypts identical plain text blocks into identical ciphertext blocks. It doesn't hide the data pattern. But some people start to use CBC and they think that they're secure with CBC. But there is something called a padding oracle attack. And in combination with like how CBC data is structured, the attacker can kind of slightly change the message and send it to the oracle. And by keeping sending these messages, the attacker is able to decrypt messages byte by byte. And because of that, CBC is not the way to go. But the thing that we recommend is always use GCM if it's possible. And this is one of the most secure things that we have for AES. And yeah, that's it. Is there anything that I missed, Jared?
I think just a couple things I want to touch on, but we should move on, is that it also covers things like the use of random number generators. Make sure that when you're creating a random number where the randomness actually matters, like for encryption or for when you don't want file names to conflict. That's not the word I'm looking for, but that is the meaning. Or when you don't want, when you want to make sure that user IDs are not sequential and random, you want to make sure that you're using proper random number generators. And generally speaking, whatever language you're working in, they will have two different random number generators. One that is just easy to use and called random, and then another one that's called usually secure random or something like that. So those are things to look out for.
Yeah. And as Jared told, like, that is important. Also, there's another thing like GUID. GUID version 5. I've seen that some clients, they use GUID version 1, which is not secure. And we should always use GUID version 4.
That's the random one, basically.
Yeah, exactly.
And then the next category, is there anything else you wanted to say on that?
I mean, we can talk hours and hours.
I know, right? I feel the same way, but we should get through this.
If we want to cover all the aspects, like, I don't know, forward secrecy and all this stuff.
We go one verification at a time.
Yeah, but we can skip that, and because we just want to go through some of the items in those categories. We can switch to category 7, which is error handling.
And I think we could probably just shoot right through this one. Error handling, this whole category 7, it's basically about not showing any error messages to the users that haven't been hard coded. So, if your application is in production, it shouldn't have, debug mode or development mode turned on. You shouldn't be having exceptions being printed out to the front end, because what ends up happening is they'll contain stack traces. Stack traces will have file names and path names, and might even have a little bit of the code of your file that's running. And these are all hints for attackers that allow them to delve deeper into your system. Just from that info, I can see what kind of operating system are you using. I can tell you, what is the language, what language and framework is used to build this app. These are all things that I can start maybe what dependencies are being used. These are all things that I can start using to find ways to break into your system. Oh, okay. This is a Windows system. They're running Node.js, and they're using, let's say, I don't know, underscore or something like that. These are all things that, there may be some vulnerability out there, some publicly known vulnerability, which underscore has many. Underscore is the name of a Node.js package. And I can try to use that to break in. It's also, you just don't want to give any hints, any extra stuff to attackers. Some of the other things you might want to pay attention to in this category are things like, so that's error handling. The other thing is logging. Don't be logging anything that's sensitive. You don't want your logs to contain anything that you don't want anybody in your company to know about, like your users' credentials or private data that your users wouldn't want some random employee knowing.
Yeah. What are some situations that you've seen, like common mistakes that the clients they make for this one?
Yeah, well, that's one for sure. Especially, so stack traces are a big one. I see that a lot. And it's one of the easiest ways to find SQL injection is you So there's all these ways to find SQL injection. One of them is, you just put a little apostrophe and see if it breaks, and then put another one and see if it recovers. But another one is you just put, and then even then it's sort of a guessing game, who knows why that broke. But sometimes you put a single quote and then it comes back with the SQL statement is broken because of the syntax here. It's like, okay, well, thank you for that information. I also now know that you're using MS SQL Server, and I know the version and all this other stuff.
That's interesting.
So,
For
the
me,
other thing that I commonly see is in logs. We commonly, because I think when you build an application, especially when you're testing, you're not thinking about all the stuff that's going into your logs. It doesn't, whether it's private or not, you're just looking for as much information as possible because it helps you to debug things. But then once it goes into production, it's important to go back and change those things, because it's very common that an application, like we see clients who they have been logging patient data if they're a health or health app, or credit card numbers, things like that.
I see. So as you told, but one of the other things that I've seen is that sometimes the clients, they think that they're not storing anything sensitive in the logs, but suddenly I show them that they're storing like bearer tokens and some sensitive headers.
Right, tokens are another one.
Yeah. The reason is that sometimes developers, they get lazy, and instead of logging exact thing that they want, they start to log the full header.
Exactly.
And they start to log the cookie, bearer token, and everything. And that's one of the bad practices that I've seen. And that's the other thing. Other than that, this category has some subcategories. Actually, how many of them? There are 4 subcategories. The first one is log content requirements. We have already discussed that we should always log some stuff, such as authentication failure, authorization failure, authorization success, deserialization failure. These are the important stuff that we need to log. And also, we shouldn't log any sensitive information. Sometimes in some instances, we have had clients that based on the compliance requirements, they shouldn't log any, even email addresses, any PII, and PII email is one of the PII pieces. And the solution was to log the hash of the email addresses, or any kind of the anonymization thing that you can implement. Right. And if you just put the hash, then there is no issue, because later on you can find which email is there, but it's not reversible actually. Right. And exactly, log processing requirements, actually we have already discussed about that. But the other issue that I see is that, especially for the clients that they have hybrid situation or on-prem environment, they start to log stuff unencrypted in on the server somewhere. And
why do you think you see that more in on-prem or hybrid situations?
Because for when they're using cloud environment, they use Azure Monitor or CloudWatch. They can send the logs there, and there's a central place, and you can encrypt that. But for on-prem environment, actually, they start to store it in any files, and which is not good actually, because they assume you store something sensitive there, and now you have an Nginx vulnerability, RC or something like that. And now in the logs they can access access token of the admin, and that could lead to bad and dangerous situations. And the access control for logs is important. And log protection requirements, as we have discussed, this is another subcategory. And there's another thing, especially in Canada and US, and we have teams that right now I'm in Vancouver, Jared is in Toronto. We have different time zones. Always we should map the logs based on a UTC time zone. We should put the UTC, because if Jared starts to use Toronto time or start to use Vancouver's time in my code, then we cannot identify what exactly has happened.
Forensics will be really hard.
Forensic would be a nightmare after that. And we would suggest to assign a unique ID for each error or exception. And always you should have a last resort error handler. And I can say like I've seen tons of 500 internal server errors, and sometimes they could be very dangerous because there is an unexpected behavior from the server, and that is something that we always should avoid, actually.
Totally.
Yeah. And category 8, go ahead, Jer.
Oh yeah. Okay. Well, I was going to say actually, so it's a nice segue because you were sort of getting into how the access control for the logs, right?
Yeah.
So now the next category is about data protection. So it's how do we protect the, I mean, it's funny because all of ASVS is about data protection, but this specific category is called data protection, and it has to do specifically with how, I mean, where you're storing data and whether it's being backed up, and what kind of data is being stored in the browser. Is it sensitive data? Is it stuff like that? So if we look through this one, there are only 3 subcategories here.
3 subcategories, yeah.
Yeah, so this, I mean, mainly when I'm looking through this, I'm thinking about the session token. Is it in the cookies or is it in local storage? Hopefully it's not in local storage. Usually you want your session token stored in cookies, and you want it inaccessible by JavaScript. Session storage would be like, a second to that in quality. And local storage would be awful, because what happens is local storage is always accessible by JavaScript. And when the difference between local storage and session storage is that when somebody closes the tab, session storage gets wiped out. Local storage just does not. It remains between all of your sessions. So if you were to close that tab and reopen it, all the data is still the same. So we want to make sure, when I'm looking through the section, I'm thinking like, where are you storing your session data? There's also some talk here about backups. Are you backing up? Are you performing regular backups? Have you tested whether or not you can restore them quickly? Then there's also stuff that's in the user's interest, which is nice. I'm glad that they added this here. So verify that users have a method to remove or to export their own data on demand. I think that's a really great.
These are for some compliance, I believe, like GDPR or the other ones. They require it.
Yeah, I think you're right. But I think regardless, this is something that should be in every application, I think. I mean,
and to be honest, some items such as 815, I believe we need to remove that from ASVS, because some of them are related to infrastructure and some of them are related to application, and ASVS should be exclusively about application security.
This is true. Yeah, this one is about whether or not you back up and
restore. This is kind of more infrastructure.
It's a bit of a gray area, but you're right. It definitely falls into cloud and infrastructure.
Yeah. Because if you want to add that, there are tons of other, like you can literally add CI's benchmark to the ASVS.
Yeah, that's true.
And
there was something here I wanted to mention that was, I think it's particularly interesting, which is we talked about how there's different, your language, usually the language that you write with usually will have 2 different random number generators, regular and secure. Well, this is also true for strings. So generally speaking, if you're using strings to store passwords, those strings get saved into memory. And if you're using, specifically, if you're using a language where there's no memory management, which is, most languages, unless you're using C or C++, I don't know, maybe Rust too. I haven't really started to dig into Rust, but I'm sure there are other languages as well. But for the most part, if you're writing code in JavaScript or Java or .NET, C# or, PHP, you name it, one of the languages that you're more likely to use for a web application, you're storing your passwords in a string variable. And if you are using a dynamically typed language like JavaScript or Python, you don't really even get control over that. I mean, for the most part, I know that there's some exceptions, but ideally you would be writing it into a different type of object that allows you to overwrite that data in memory. And a lot of languages actually offer that. Java, for instance, has, I don't remember, but Java and .NET, I know for sure there's a string, and then there's one called, it's some kind of a mutable string, so that God, it won't come to me in the time that I'm trying to think of this. But it's a string that lets you overwrite all the data with zeros, so that after you're done using a password or a key, you can erase it from RAM, from memory. For languages like JavaScript and Python, it's a bit more difficult, but there are ways to force garbage collection. Anyways, I thought that was an interesting one to cover, because I was
for Java, actually, as you told, like the string is immutable and cannot be removed from memory, I believe.
Yeah,
but the safest option is a string builder. Actually, we can use a
string builder. Thank you. That's right.
Yeah.
It has a method that I think is called clear, maybe write, and you can just write zeros.
Exactly. Yeah. And that's good. And I believe we can wrap it up here, Jared, because like we've gone through 3 categories.
Yeah, sure. So why don't we just say, coming up, like we have in the next episode, we'll be talking about the communications category 9, which is about TLS. We'll probably go through that very quickly. So then we'll end up talking about malicious code verification. We'll probably go through that very quickly too. A lot of this has to do with, having an antivirus for file uploads. And then business logic verification, which will be category 11. That one we'll probably spend the most on, I think.
Yeah, awesome. Yeah. That's great. And that concludes this episode of AppSec Insiders Podcast. We hope you've enjoyed learning about OWASP ASVS. And also, there are some upcoming events, which are Money 2020 in Las Vegas in October 22, and also LastCon in Austin in October 26. And also, remember to tune in next time as we delve deeper into the world of application and cloud security and explore new ways to protect our digital assets. Also, we always appreciate your support and engagement. And if you have any topic in your mind, please don't hesitate. Reach us out. Reach out to us at appsecinsiders@forwardsecurity.com. Our Twitter handle is @FWD_SCC. Or feel free to follow us on LinkedIn. And please consider subscribing to our podcast, and have a good one.